Good morning everybody, it's Sultash Maths Tutor, and today, because I've been asked, I'm going to be looking at differentiation of x over 2 and how you get the derivative of it, because it actually brings out a few things of interest. I guess this is aimed at sort of AS level maths or A2 maths, and so therefore some of the things I talk about, if you're unsure, there are videos in other playlists which will explain some of the stuff I'm just going to assume that you know. But firstly, let's look at, before we get to x over 2, by way of a route into that, let's look at say 4x, and I want to take the derivative of that. So sort of very casually I could say, well, dy dx of 4x, well, here's the first thing. I can rewrite that and take the coefficient, which is the 4, and put it out the front, and so I end up with dy dx of just x. And many of you will know, I'm sure, instinctively, that that just becomes 1. So in fact the answer is 4 times 1, which is 4. And sometimes in differentiation you just get to understand that if you see an x value, then it just becomes the coefficient once you dy dx'd it, once you've differentiated it. So 7x, the differential of that is just 7. It becomes a little bit easy. But why is that? Well, if we take any function which is x to the power of n, if we take the derivative of it, then what we do is we still have the x, but we do n and we take away 1 from the power, and we put the original power or indices as the new coefficient. And how does that apply to 4x? Well, let's change colour. Let's change colour. Does that resemble 4x? Well, yes, sort of it does, because I have 4x, and you remember from indices that actually x is x to the power of 1. So when I take the differential of 4x to the power of 1, well, I can, let's just move this, I can bring the 4 out the front here, and I'm left with x to the 1. Well, we know that that is going to give us, well, the coefficient that I shoved out the front remains the same. Now I'm going to look at applying this to this. Well, I have x to the 1 minus 1. There is my n value, and there is my minus 1, and then the n comes down to the front here, so that's 1. Now, what I know is that 1 minus 1, because we're all super duper clever, is in fact 0, and anything to the power of 0 is 1. So I end up with 1 times 1, which is 1 times 4, which means that the answer is just 4, which sort of bowls out what we intuitively thought. Okay, a little bit long-winded, but that's how it works. So, if we had something like, well, we had 7x, didn't we? Let's have 8x. We had 8x, and we want to take the derivative of that. Well, dy dx of 8x, the derivative of 8x, well, I'm going to, equivalent sign is equivalent to 8 dy dx, and I'm writing it out all in full here just so you get the flavour of this. X to the 1, okay, so that equals 8, x to the 1 minus 1, bring the power down is 1, put it just like that just to keep it separate, and so we have 8, 1 times x to the 0, which equals, well, that all equals 1, so it's a very long-winded explanation there, but just to show you that it's easily doable. And 5x. Well, I'm not going to go through that explanation again, but we know that that's going to turn up as x. It's interesting how in all of these examples we've concentrated on the x, but actually that coefficient is sort of just gets pushed aside, doesn't it? How does that relate then to x over 2? Well, where's the coefficient there? And this is where, gang, we have to start thinking a bit laterally. Yeah, it is x over 2. You're absolutely right, it is x divided by 2. But think about it almost as a, and I'm shuddering to say this for all of you, think of it as a fraction. In fact, think of it as a fraction multiplication, because x over 2 is the same as a half times x, or if I wanted to be absolutely pedantic about it, x over 1, but we don't normally need to write that. Well, if I compare that to 5x, that's the same as 5 times x. And when we differentiated that, we just shoved the 5, we sort of disregarded the 5 really, and shoved that out the front of the differential. And that is exactly the same as what we do with this baby. So if we have x over 2 dy dx gives me, remember I don't have to shove the half here, I don't have to do that, I can just keep it inside the differential. It gives me half x to the 1. I now apply my standard x to the n equals n x to the n minus 1. I wonder if this will work. Ooh, box, super. that's my standard result that I'm going to use. So that gives me half, and I'm going to do it all the way here, times, well, the n here, this is that is the n, so that 1 comes there, x to the 1 minus 1, which equals half times 1 times x to the 0. Notice I'm really labouring the maths here and writing everything out. You wouldn't be expected to do this. Which equals half times 1 times 1, because that's what that becomes. And that's a half. And that's it. So therefore, the derivative of x over 2 is a half. You could take that even further. You know, now it's suddenly become any fraction of x. X over 4, well, that's the same as a quarter times x. Dy dx equals a quarter. Just literally popping into my head, I've suddenly thought, well, how about 5x over 7? Can you see what it's going to be yet? Yeah, it's the same as 5/7 times x. Do the dy dx thing on this, and you end up with dy dx of 5 over 7x equals 5 over 7. Okay, that has been it, everybody. This is Salt Ash. He speaks as he writes, maths tutor. If that's been of any help to you, then absolutely brilliant. And if you've got any comments, fire them in. I'm always happy to listen. Thanks very much.